Our next speaker now at 16:30 is Bastian Bloessl, and he's contributing online, and he should be here on the screen already. Hello, Basti. How are you?
Hi, and nice to see you. Great.
Well, so you're going to talk about a cool project called Seify.
Yeah.
Is Seify somehow related to soap?
Yes, exactly.
That's what
kind
I
of
thought.
The Rust version of Soapy. Yeah.
Interesting. Yeah, I've been working with Soapy, of course, as many of you probably have, and it's an important piece of glue software, and that's interesting. Absolutely. Basti, we've pre-recorded your talk also, like with all the other talks. Good to have you here. And dear audience, please note down your questions. You will have the chance to ask them later to Basti, who's already waiting for your questions. So, dear video team, please play the pre-recorded talk.
Hello, everybody. Thank you very much for the chance to give a talk and to present to you my new project that I call Seify. And yeah, Seify is another Rust software-defined radio project that kind of complements other projects that I started in this realm. So, namely, this is Future SDR, a project that I talked about at last year's Software-Defined Radio Academy. And I'll also come back to Future SDR later in this talk. Yeah, Seify is a Rust software-defined radio hardware abstraction library. And what it basically means is that it provides a common API surface to implement various SDR front ends, like to interface the HackRF, the RTL-SDR, UHD, you name it. So you already guessed it probably, it's exactly the same problem that Soapy SDR is already solving in C++ domain. So you might wonder, so why should I listen to this talk if this is a problem that is already solved? But I think there are three main reasons for that. And first of all, if you want to make progress, if you want to push this Rust SDR ecosystem further, then at some point we just need such a library, so it has to exist. Then second, I think Seify has some new concepts and ideas that are hopefully also interesting for you, so how you could improve things, let's say. And finally, there's also a perspective for the user, so for the person that is running the SDR application. Because with Seify, I think a lot of this hassle with getting the system up and running can get much easier. So hopefully this is kind of interesting for you. Yeah, but speaking of the end user, I also want to make a short disclaimer. So Seify, I didn't just rewrite whole Soapy, including all drivers and modules or whatever. So Seify is not a ready-made product or whatever. If you are not into looking at code or coding a bit, that might not already be for you. Even though you can already use it, you will see demos in the end. This is exactly what's on GitHub. So it's already useful, but it's not necessarily a fully fledged ready-made product. So just as a disclaimer. Okay, so let's start with a very quick introduction about me. I'm Bastian Bloessl, and I'm currently a substitute professor at the University of Paderborn, where I'm leading the computer networks group. So, what that basically means, I am giving a lecture on systems programming. Research-wise, I'm with TU Darmstadt, where I'm part of the Secure Mobile Networking Lab. And my research interest is mainly about software-defined wireless communication systems. So that means I work a lot with software-defined radios, trying to build SDR frameworks and cool new fancy applications, where my focus is mainly on the systems-related aspects. So that means how you can get these things up and running, how you can implement this in a good performant way, let's say. And so in a sense, it's also the computer science perspective on this SDR topic, so to say. And if this is something that interests you, if you want to write a thesis, if you want to do a PhD or whatever, you can feel free to contact me, either as a co-supervisor or sometimes or often we have some positions. So if you are interested in these topics, feel free to contact me. And yes, finally, I'm also a maintainer of Future SDR, and this is a software project. I already just mentioned it, is where I talked about last year's Software-Defined Radio Academy. And I don't want to go in detail now. It is a software-defined radio framework. You can think tries to solve similar problem as GNU Radio, but GNU Radio has a nice GUI. It has a lot of third-party code. It also has a lot of blocks that come with GNU Radio, and Future SDR is not there yet. But it has some interesting features that I think are very interesting to explore and has some unique advantages. So it is, I think, obviously I think it's an interesting project, and if this is a topic that you might find interesting, then you can go to this URL. On the front page you find the video of last year's Software-Defined Radio Academy, so you can learn a bit about Future SDR. Yeah, but yeah, Future SDR, as I said, is a software-defined radio runtime, and obviously that has to interface hardware. So last year when I talked about it, the problem was basically solved from my perspective, because there's Soapy in C++, which is providing you drivers for most all relevant SDR frontends. And there is a Rust wrapper for this Soapy library, and Future SDR was just interfacing this Rust wrapper, had sources and sinks for Soapy, and problem solved. Basically, it means we had support for most or all relevant SDR platforms. So that was last year. And then, yeah, recently I got my hands on, for example, there was some new hardware. So this is the Aaronia Spectran, for example. And yeah, I think when I got this, first they started some C driver, but it was not really ready, and it could only receive and not transmit. So anyway, I needed a Rust driver for it, so I wrote this on my own. And as we will also see later, these devices, they have a mode where you can read the samples through a HTTP server, or you can push some samples in this HTTP interface, and then we'll send them out. So you anyway don't need any fancy system libraries. Let's say you can just very easily write your own driver. So this is what I did. But then I ended up having in Future SDR, okay, I have the Soapy source and I have the Aaronia source and sync. So I already had two. And then there were even more good news. So for example, there are very interesting projects that started, I think, in the course of last year or so, where people, for example, start to implement pure Rust drivers for some hardware frontends. For example, for the RTL-SDR or the HackRF. And what this means is this doesn't use Soapy or this Soapy plugin for this driver or lib-RTL-SDR or lib-HackRF or whatever. No, but this is the Rust code that is based directly on top of libUSB. And you don't even have to have libUSB installed, because you can just compile these projects on a system, and the only dependency it has is libUSB, and if it's not found on the system, it will just compile itself statically as part of the normal Rust compilation process, where you don't have to deal with anything. So that means these things can run very, very easily. There's no hassle with shared objects, libraries, stuff that is not compatible, that is part of your distribution management, or you cannot have different shared objects installed on your system and have a lot of hassle with this. So basically what you need on your system is a Rust toolchain and something that looks like a compiler, and then it will either use libUSB if it finds it on the system or compile it in. So this is very, very easy to get up and running. I think this is as good as it gets. The only thing you might still need is UDEF rules to tell the system, a Linux system, that a user gets the permissions to interface with his devices, but there's no way around it. Other than this is just plug and play and no hassle with libraries or whatever. So obviously these two libraries I also wanted to support in Future SDR. So okay, so I need another source for the lib-HackRF, for the RTL-SDR, and sources and sinks for the HackRF. So okay, I was already seeing in my mind all these different sources, and then the question is, okay, now when I make some example flow graphs, which sources do I use? Because I don't know what the user will have. It's connected to the system. So you see, yeah, obviously I was at the point where I realized, okay, I need Soapy, but now I need it for Rust. And yeah, this is where I started basically the Seify project, and this is what this talk is about. So Seify, I already said it in short, it's a SDR hardware abstraction library and solves similar problem to Soapy. Seify is German for soap, so hence the name. Yeah, and I hope it's not just a rewrite in Rust, as I mentioned, but that hopefully you see there are some interesting concepts there. And also it's an invitation to collaborate, because obviously I did not implement all hardware drivers, but just a few of them. So there's a lot of cool stuff to do there, and hopefully, I hope it will gain some traction in the future. So in the rest of the talk, I want to say about first of all, mention some things that are similar or exactly the same as with Soapy, and then some things that I did differently. Let's start with the things that are exactly like with Soapy, because I think some things that Soapy really did great is the API. I really like the Soapy API, and it's great, and Seify just adopts it. There's nothing, it's at some points it makes it a bit more like the Rust way to do it, a bit more, it adapts a bit slightly the function calls to make it more typical for use in Rust. But API-wise, it's a direct translation. So if you have some code that's using, in C++ that's using Soapy, it should be trivial to port it over to Seify, let's say. And the second thing it uses, this is also just directly taken from Soapy, is this device arguments. Probably if you already used Soapy, you know this strings that contain key value pairs to, for example, specify the driver or make some configuration for the hardware, like changing the motherboard or the output port mapping, whatever you can imagine. So Soapy has this famous like strings that contain key value pairs, and they're also that are called args. And I just also have this in Seify, where I can create some args that are strings that contain key value pairs, like driver, the driver, so it even supports whitespace, ID is a number, and then there's some other key value pairs. And these arguments, you can do the normal things. You can also manually set some key value pairs. You can merge two arguments together. This is rather boring. Then the interesting part is the way it works is that internally these arguments are, you can think of it as hash maps, or maps that map the key to the value, and both are strings. But then you can get the value out also typed, and every type that can be created from a string, so there is in Rust a from string trait. So every type that implements this from string trait, you can try to get out of this dictionary. So this call here, it basically means look for an ID and try to parse that as an integer, so as an unsigned 32-bit integer. And here in this string, in this case, we have the ID equals 1, 2, 3. So it can parse this out. And with Rust, there's this very famous SDR crate for serialization and deserialization, and there's even support for this. So that means if your driver needs a complex structure that it needs to kind of parse out of these arguments, this is very easy to do. So here's an example struct that's just called config. And this one, it has a driver that is a string, and it has an ID that is an integer. And you just define this struct and don't have to do anything else. And you can then try to get this or deserialize out of these argument strings. For example, here we deserialize out such a config. And what it does internally is it will look, is there a driver? Is this a string? Everything is stored as a string. There is no question whether this can be a string. So it always is a string initially. So they have to have the driver is then the string, the driver. And it then looks, is there an ID? And can it parse this ID as an integer? And in this case, that works. And so you can deserialize such a config struct out of it without any further code. So this is just kind of working out of the box in Rust, thanks to this SDR crate. Okay, so this is why we did exactly the same thing as with Soapy. And now let's see where things are differently. So a bit the downsides of Soapy is that, yeah, there's a lot of levels of indirection. So let's think about RTL-SDR, for example. So it's based on libUSB. Then you have a hardware driver, RTL-SDR. Then you need a Soapy driver for the RTL-SDR. And then you have Soapy, and then anything on top, like in radio, or here for Rust domain, there would now be the Soapy Rust crate, and then future SDR behind this. And here you see a lot of, so each of these components here in black is a shared object, is a dynamic library somewhere on your system. And each of these arrows basically means a lot of headaches, a lot of issues, frustrated people, issues on GitHub. Because, usually it's not easy. Get the right libraries, get the right versions, have maybe some come as part of your distribution, some you compiled yourself, they are in different locations, they are same libraries with different versions, and yeah, a lot of things can go wrong if you just look at the issue tracker for SDR. Often it's something that is based on shared libraries. And yeah, as I already said, if you go for this, like the Aaronia driver, it's just interfacing HTTP, so there's none of this. If you go for the pure Rust drivers that are popping up now, then all this goes away. Basically, it's just built on top of libUSB, and as I already said, it doesn't even need this to be available on the system. It'll just vendor it or statically compile it in. So this is one of the differences. Another difference is that you have system-wide installation of modules usually with Soapy, and your package manager usually installs libsoapy modules all, or however it is called. So usually the typical workflow is that you have a lot of modules on your system somewhere, and then when you want to start a Rust SDR application, it will probe the different modules. And often modules, one of those modules might have a bug, for example, with the audio source, the real-time audio, so it's just probing. Maybe you don't want to use audio, maybe you only have an RTL-SDR or something connected, but it will probe all Soapy modules, one of them crashes, whole application crashes. Not so nice. Or something that caused us a lot of pain in the lectures last year is that, for example, some applications like GQRX or SDR++, I think, for example, for the HackRF, they had a native driver, and then they also had a Soapy driver, but Soapy also kind of indirectly supports the HackRF. So for the hardware, there were basically two competing drivers. They were not synchronized, so everything crashed. It's also kind of causing some headaches and some frustration in the exercises. So yeah, this is a bit, let's say the downsides. And if you look at Rust, then this is not something that I did or whatever. So basically, this comes just from moving to Rust and having this pure Rust implementations is that you have the zero installation. But obviously, Seify, we support Soapy. Soapy is the thing that is used in basically 99% probably of the users, and it will not go away in the next 5 to 10 years, I'm pretty sure. So we also support Soapy, but we also support like this pure Rust stuff, and then we can just add more and more Rust drivers and always use Soapy as the fallback or default, let's say. And that means that over time we can, if the ecosystem hopefully gets better, we get more Rust drivers, we want to use them, then this kind of fallback, the Soapy fallback, will be used less often. And you have also in Rust, usually you have these feature flags, and there you can easily say what you want to have compiled in and what you don't want to have compiled in your binary. And with Seify, every hardware driver is a feature, and so you can easily say, I want Soapy, I don't want Soapy, I want the RTL-SDR, I don't want it, I want Aaronia, I don't want it, whatever. So you only selectively compile into your binary what you want, and the rest is not in your binary. So if you just use an Aaronia, no need to have any Soapy or what interfaced by your library. We'll have this in the demo. So there's a lot more to say about Seify, but for this talk I want to focus on one last aspect, and this is typed interface versus dynamic dispatch. And what this means is with Seify you can do both, and probably the most common one is dynamic dispatch, and this means that you just tell Seify to look for a device and just open one. Or maybe define some constraints through these arguments. But anyway, you just say open a device, and you don't know before you call it if it will be a HackRF or RTL-SDR or whatever. So it will use some generic code that will interface any device. And that means that during runtime, it has to decide which functions, implementations to call, depending on what kind of device it used. So there's a tiny overhead that you probably have to pay during runtime. For a lot of Rust people, it's very important that everything is typed. So this is also supported in Seify. In this example at the bottom, you open RTL-SDR, and then you create a Seify device from it. And this device will be fully typed. So that means that during compilation, it will be monomorphized, which in turn means that you create machine instructions code that is specific for this kind of Seify device with this driver implementation behind the scenes. And that means there's no overhead to pay. So there's no dynamic dispatch. There's no kind of generalized things that have to be there to support all kinds of devices. No, it will be compiled down specifically for this driver. And that means there is a kind of a zero-cost abstractions. And with this, I hope that there's really no reason not to use Seify. At least this is, from my perspective, the main goal. So as someone who implements a driver, you can implement the minimal Seify interface, create a Seify device from this, get a lot of nice features just from wrapping it in a Seify device. And at the same time, you don't have to inherently pay a price for this, or you refrain to dynamic dispatch during runtime. So really, there should be no reasons. It's the point to not use Seify. Okay, so yeah, let's look at a very small demo. Here I'm in the Seify project, and it comes with several examples. In this case, I want to show the probe example, which tells you what hardware it found. At the moment, it finds, the output could be nicer, I know, a B210 that's using the UHD driver. Okay, this is expected. And yeah, that is available through Soapy. And then there is an RTL-SDR that is also made available through Soapy. So at the moment, 2 devices that I can interface through Soapy. And this is because if we look at the project configuration of Seify, it's these features that I already mentioned. So this is nothing specific to Seify. If you know a bit about Rust, then you will already know how to handle these things. But that means per default it will always just enable Soapy, because I guess this is what 99% of the people will use, and everything else is disabled. But we could just as well use the pure Rust RTL-SDR driver or the Aaronia HTTP driver, for example. So I have a Aaronia connected, so I can do features equals Aaronia HTTP. And now it hopefully also found the Aaronia. Yeah, here it is. So now it found the Aaronia device because I enabled the driver. What I could also do is disable Soapy. Then I just find the Aaronia. And the nice thing is that the binary that I produced now, it just links against some system libraries. No Soapy, no hardware drivers, no nothing. This is something you can compile on any system very easily without any hassle. So, okay, but this shows you how you can enable and disable the Seify drivers. And just to demonstrate that they are actually working, here is an example. So I have an Aaronia connected, and this is their GUI. In this case, I just have a very trivial setup where I have some graphical outputs, and at the bottom here is an HTTP server where I can pipe some of the samples into the HTTP servers, and to decide which parts of the spectrum I basically want to cut out, there's this IQ demodulator. So it's actually a bit of a misnomer. It's actually a channelizer, not a demodulator. Okay, so this thing is running here, and here we have the wireless LAN receiver that comes as part of Future SDR. So now we could try different things. First of all, let's just run it. And also in this case, the only thing that is enabled by default is Soapy. Soapy finds the RTL-SDR and the UHD, and it tries with the RTL-SDR because it's the one that finds first. And I see that doesn't support the 20 megahertz sample rate for Wi-Fi. So what you could do is tell the Soapy driver and say, Soapy, please use UHD. So now we already saw, okay, it used the B210 through Soapy, and here 5.22 gigahertz is, I looked it up, channel 44. So set the corresponding Wi-Fi channel, and now we receive some frames. Okay, so now what we could do, instead of the going through the UHD, so that using the B210, we can also say again no default features. Then probably we end with we don't have any driver installed, but we can again enable the Aaronia. So that works, but we also have to tell it where to tune to. So now it again tunes to the right point in the spectrum, and to show you that, yeah, it's auto-tuning, we can just tune somewhere, restart it, and it will configure this. It also will use a slight DC offset. And here it receives some Wi-Fi frames, and if you're interested, yeah, they are actually received. So we have here Wireshark running, where you can see the decoded frames. This is not a wireless LAN card in monitor mode, but these frames really come from the SDR. You can see that because this actual payload is wrapped in UDP through the RF tab protocol, which is designed to basically wrap decoded SDR frames and forward them to Wireshark and then use the actual dissector. And because you can see on top of RF tab, there's now the wireless LAN dissector. In this case, this was an egg. In this case, it's a beacon from a Fritzbox, and so on and so forth. So yeah, this is actually working. And this also shows a nice thing about the Aaronia. For example, sometimes there are these bursty errors. Now you saw them, and I was wondering with the B210, why is this occurring and what's going on there? And as you can see, this is because some of my devices support high bandwidth mode, and this is just something my 220 megahertz wireless LAN 11A receiver is not used to. That means these burst errors always happen when some device uses the high bandwidth mode. And this is something it's hard to debug with the B210, and with the Aaronia it's very easy to see. Okay, so that should be it for the very brief demo. And yeah, so we talked about Seify and the Rusty hardware abstraction library for your SDR. And I hope, you like the talk. I hope you get interested into the project and check it out. It's on GitHub under the Future SDR organization. And yeah, I hope you help or jump in and create an awesome Rust software-defined radio ecosystem. Okay, thank you for your attention, and now I'm open to questions.
Okay, thank you very much. Interesting project. Still don't know where I'm going to try it out myself, but I'm pretty sure in the next couple of months I will have an opportunity to, or find an opportunity to try it out. Personally, I must say I haven't been into Rust yet. I'm more a Python and C++ kind of person. But yeah, Rust and Go, they both have a strongly growing community. And there are reasons to go away from C++. And yeah, it's more a matter of time, but I think still it's very rewarding to go into these programming languages and try them out and see which advantages to get out of them. So
yeah, I think there are some technical arguments, but for me mainly it's much more fun to program in Rust at the moment. So yeah, that's the main reason. That's why.
Yeah, are there other questions to Basti? Who's been trying out Soapy? Who's been using Soapy? Okay, a couple of people. Your experience with Soapy? Soapy good? Bad? No, we don't want to be evil about and denounce software projects because they're all pretty much work. But well, every piece of software has advantages and disadvantages. We know that. And
yeah, it's the same for GNU Radio also with the out-of-tree modules and third-party modules. When you always run into problems with shared library, so a lot of people struggle with it. So it's nothing that is really specific to Soapy. So it's not to blame. And as I said, also, first of all, I use Soapy a lot. It's still the default, and it's just that with a lot of modules and shared objects and levels of indirection, a lot of people just might run into problems. So
yeah. Well, questions? We have a question.
Yeah, if using Seify, do you getting better round trip latency between the receive and transmit in theory, because everything can be better integrated?
Yeah, I mean, it's at this point very theoretic because the drivers that I currently re-implemented in Rust, they don't have the, let's say, quality, stability, and nothing like this than the other drivers. Conceptually, it should be able to provide theoretical advantages. How they really, if this will really be kind of measurable or make a significant difference, I don't know yet, to be honest. But the things I mentioned about this typed interfaces, you could really then compile down code that is really specific to the device. So you, in theory, it could be better, let's say. But if this will be measurable or significant, I don't know yet.
Any more questions? No more questions? All right. So, Basti, thank you very much for sharing this very interesting project.
Yeah, thanks for having me.
Thanks very much.